Hello everyone and welcome to this new tutorial in vector operations. So what are the different vector operations we're going to talk about? You have the magnitude, which is the magnitude of a vector or length of a vector. U in absolute symbols is equal to square root of ux squared, which is the x value or like the x-axis value, plus uy squared, which is the y value, plus uz squared. Like you can consider it as a point, except it's not a point. Ux, uy, uz are the coordinates of the point, and that point, okay, together with the origin, defines the direction of the vector, and the distance from that point to the origin define that magnitude or the length of this vector. Determinant or cross product, u cross v is equal ux vy minus uy vx, as you see here. It's like the determinant of a matrix, ux times vy minus, always you have plus going down and minus going up, minus uy times vx. And the dot product, which is u times v, actually not times v, dot v is equal to ux vx plus uy vy plus uz vz. Of course, when we're talking about a three-dimensional vector, is equal to the modulo or the length of u times the length of v times cosine theta. We can actually find the angle between these two vectors using this formula as well. Let's start with creating the function that will return the magnitude of a vector. Double magnitude. It takes one vector of type double, which is an array, and the length of this vector. We create an integer I for the loop, and double m equals 0, which is the vector sum that will keep adding up, x squared plus y squared plus z squared. For I equals 0, I less than len, I plus plus, m plus equal power of ui 2, which is x and y and z added to the power of 2, or raised to the power of 2 and added together. Finally return the square root of m. Distance between two vectors, double vector dist, double u, double v, and the length. Of course, they need to be of the same length. And I double s, the sum that will keep adding up. The same method of getting the magnitude with some change. For I equals 0, I less than len, I plus plus, s plus equal the power of ui minus vi. To the power of 2. Return the square root of s. Here's how it works. So it is x of the first vector minus x of the second vector squared plus y of the first minus y of the second together squared plus z minus z of the first squared, all of them, and we get the square root for the distance value. As a reminder, here is what we're working with. So for the magnitude of the distance between two vectors, instead of having square root of ux squared plus uy squared plus uz squared, it is the square root of ux minus minus vx squared plus uy minus vy together squared plus uz minus vz squared. As for the dot product, the dot product between two vectors is ux vx plus uy vy plus uz vz, which is also equal to the length of u times the length of v times cosine theta. The function to get the dot product, double dot product, w, the first vector, v, the second vector, and the length of both vectors. Int I double s equals 0 because there's a sum. For I equals 0, I less than len, I plus plus, s plus equal ui vi. Finally, return s. To get the angle between two vectors, cosine theta equal n1 dot n2 divided by the length or size of n1 multiplied by the length of n2. Now, of course, you get here the cosine value, not the angle. So, to get the angle, you need to measure the arc cosine of theta. You use the a cosine or arc cosine of theta to get the angle, but the value given is in radian. To convert it to degrees, you need to multiply it by 180 and divide it by the pi value, which is 3.14. Double angle, the function to get the angle between two vectors, double u, double v, and len. Double dot product equal to, we call the first function dot prod u, v, len. Double the magnitude of u equal magnitude u len. The magnitude of v equal magnitude v and len. Finally, the cosine value equal the dot product divided by the magnitude of u times the magnitude of v, which is the formula we saw previously. Double radian, the angle in radian is equal to a cosine of the cosine value. Finally, the degree, double degrees, is equal to radian times 180 divided by the pi value. Okay, let's declare the pi value as a constant. And here we return degrees. You go to the top of the program and you write double pi is equal to 3.14159. And we use this value as a constant. Okay, we need to declare before it const as a keyword. Let's save the program. So again, at first the cosine is the dot product of u and v divided by the magnitude or length of u times magnitude of v. The radian angle is equal to a cosine or cosine to the power of -1 of the actual cosine value, and degrees is equal to the radian value multiplied by 180 divided by pi, which is a constant double that has been declared, and finally return degrees. The cross product for a simple vector 2D vector or simple 2D vectors, the cross product would give you a value which is like a determinant actually. So u cross v is equal to ux times vy minus uy times vx. As for 3D vectors, the cross product would go like this. You have three coordinates for a vector. The product actually, the outcome of the product is a vector itself. So you get I times, and you see here's where the column and line cross. So you bar these two and you multiply the ones underneath these intersections. So I times uy vz minus vy uz minus here. The next one would be multiplied by minus, which is j. So minus j times ux vz minus vx uz plus k, and k intersects here, times ux vy minus vx uy. Before creating the function that will return the cross product, and as we mentioned, the cross product of two 3D vectors actually returns a vector itself. So we need a structure, data structure, that will have the three values of x, y, and z within it, and that will be the vector returned by the function. So let's declare a vector as a data structure, type def struct. This vector has three variables, which are double x, double y, double z, and the name for the data structure is vec, because I think the word vector is preserved within C programming. Let's then create the function that will return the cross product as a vector. The data type returned is vec, it's a vector. So vec cross prod w, the first vector, double v, second vector, and the length of the vector. Vec cp, we are declaring a new instance for vector. Double x is equal to u1 times v2 minus v1 times u2. Y is equal to minus, here we have j that is negative, so u0 times v2 minus v0 times u2. Finally, double z is equal to u0 times v1 minus v0 times u1. cp.x is equal to x, cp.y equal y, cp.z equal z, and finally return the cp or cross product vector. I will also create a void, which is not a function but a procedure that will display this outcome vector. Void display vec, we will call it. It will take a vector w, and the name for the vector would be also an input so that we can change it. Double x is equal to w dot x, double y equal w dot y, double z equal w dot z, and let's print it. Printf percentage c, which is the name for the name of the vector, percentage f, and the first argument is the name, which is a character, then x, y, z. I will display this same vector using a different type of presentation. Percentage c is equal to percentage f I dot I. But here we're not multiplying, it's just a display. Percentage f is the value multiplied by I, then plus percentage f dot j plus percentage f dot k. Name x, y, z. That's it. Now let's run it through main. At first, let's declare two vectors. W of size 3 is equal to 3, 2. Double v, the second vector, also 3 values for simplicity, choosing small values, 1, 0, 1. Vec w, let's start with this, equal cross product of u, v, 3. Distance, double dist, is equal to vector dist of u, v, 3. The angle, double a, is equal to angle u, v, 3. Let's print the distance between u and v, percentage f, and that's the distance, which is this declared in the second line above, this one. Print f, angle between u and v, percentage f, degrees, and the variable is a. Finally, printf the cross product, and we call the procedure display vec w, and the character is w. I'm adding another line breaker. Let's run. And here are the results. Distance between U and V 3.16 to 278. Angle 55.46 degrees. Cross product is 3, 1, minus 3. Or W equals 3I plus 1J minus 3K.